here we're going to look at topic 74, example 4, complete the square to solve a real-world problem. So Libby plans to create a rectangular pasturing enclosure. She has 340 meters of fencing available for the enclosure's perimeter and wants it to have an area of 6,000 meters squared. What dimensions should Libby use? Okay, so the first thing we want to do is set up a formula, or set up as many formulas really as we can. And one of the first formulas that I'm going to notice is that they mention the perimeter. And we have 340 meters of fencing. So I know that the perimeter, my formula 2L plus 2W, has to be equal to 340. All right, and that's based on the perimeter. Right, so what we want to do is want to isolate a variable. It doesn't really matter whether you pick W or L in this case. I'm going to isolate W for no main reason. I'm not picking that over L for any specific reason. So we would subtract 2L, and we'd have 2W equals 340 minus 2L, and then I would divide everything by 2. So W is equal to 170 minus L. And that'll become pretty useful, but we want to look at the next part of this. So now we've kind of exhausted our perimeter. All right, we can't really do anything else with that. So let's look at the area. We know area is equal to length times width. We know Libby wants an area of 6,000 meters. So we can plug in 6,000 for A. Our length is just going to be L. And then for W, we're going to replace W with 170 minus L. So 170 minus L, and we have that. So we then distribute, and we can solve for L since it's the only variable in this problem. So 6,000 would be equal to 170 L minus L squared. We're going to rearrange this. We want so we're trying to operate, right, with ax squared plus bx plus c. Probably going to be completing the square, but we want our A term to be positive. Right now that L is a -1, so we want to fix that. So I'm going to do two things at once. I'm going to divide everything by -1, and I'm going to rearrange the pieces. So I have -6,000 is going to be equal to L squared minus 170 L. So what I did there is all the signs were changed, and I just swapped the order of the -L squared, which now becomes L squared, and 170L, which is now minus 170L. So from here, we're going to complete the square. So we want to do our B over 2 squared, and we're going to use -170 as our B value. So -170 divided by 2 squared, and when we simplify that, we would get -85 squared, which is 7,225. So that 7,225 is going to get added to both sides. And when we start to clean this up, you get 1,225 is equal to, if we were to factor this, actually let me, so this 7,225 is here and here. This would be L minus 85 squared. And this number here, whenever you factor these, this number, I don't know why it keeps doing that. There we go. Winds up being the number that was here. So that kind of works out that way. So we'll now take the square root of each side, and we can solve for our variable of L. So square root of 1,225 is positive and -35, with L minus 85. So we create our two equations, right? L minus 85 equals positive 35, and L minus 85 equals -35. Solve for L. So L is equal to 120, or L is equal to 50. Now, sometimes you'll get a positive solution and a negative solution. Since we're talking in terms of distance or length, in terms of measurement, our solutions would have to be positive. In this case, both of them are positive, so either one of these could be a solution. So we want to kind of plug this in and see what happens. So L, we know that W, going back to over here, we know that W is equal to 170 minus L. And we have two options for L. We could do 170 minus 120, and then W would be 50, or W equals 170 minus 50, so W would equal 120. And notice that they're pretty much just the opposites of each other. So either we have length of 120 and width of 50, or we have length of 50 and width of 120. So it doesn't really matter, whether we consider the 120 our length or width. They wind up being the same thing. But what happens is that we want, Libby should make two sides 120 meters and two sides 50 meters. And that'll give her the perimeter that she's looking for, and also maximize, or maybe not maximize, but give her the area of 6,000 that she wanted. Not the easiest of problems, or not too bad of a problem, but a lot going on, a lot of steps to show. And if you set up the perimeter and area, most of these problems, these type of problems, are solved pretty much the same way. You isolate either W or L, and then let's say in the perimeter I had isolated L. You would do the same thing in the area section. You would just have a W in place of all the L's in that whole problem. So you wind up doing the same work. Doesn't matter whether you isolate L or W.